Hey guys, I'm back with a new video. So in this video, I will be showing how to design power circuit and control circuit of a grinding machine. So let's get started. So see, what is the topic? So the topic is to design power circuit and control circuit of a grinding machine's motor. And see what are the sessions outline. The requirements, motor connections and star delta configuration, then notations, and finally the power circuit and control circuit. So at first we will start from the requirements. So what are the requirements? See, there is a 30 HP motor. So motor greater than 10 HP requires star delta starter. So I have to incorporate star delta starter. Also I have to incorporate emergency stopping mechanism. For that I have to incorporate DC injection braking system, right? See here. See the motor connection and star delta configuration. See, this is star configuration and this is delta configuration. What I have done, I have taken the three windings. Three windings have 6 terminals. So I named the terminal A1, A2, B1, B2, C1, C2. Okay, and I've shorted C2, B2, A2, made a star or Y connection. Okay, and here in delta, what I've done, same, there are 3 windings, 6 terminals. What I've done, I have shorted A1, C2, A2, B1, B2 and C1. And from A1, C2, I have taken out one terminal A. From B1, A2, one terminal B. C1, B2, one terminal A. And here also from A1, one terminal A. B1, one terminal B. C1, one terminal C. Like this, I have made 2 configuration. One is star configuration or Y configuration, and the other one is the delta configuration. Okay, is it clear? It is very easy to understand. Okay, and see here, this is terminal box connection. So this terminal box, this is the motor's terminal box. I've named A1, B1, C1, A2, B2, C2. Okay, I've made the connections. What I've done, see the phases are coming, A phase, B phase, C phase. These phases have been connected to A1. I've connected these phases to A1, B1 and C1. And for achieving Y configuration or star configuration, I have to short, what I have to do, I have to short A2, C2 and B2. That only I have done. I shorted A2, B2 and C2 right here. And this is a contactor. Okay, this is a contactor. This slash symbol represents, here slash symbol represents contactor. So by incorporating a contactor, means via the contactor I'm shorting these connections. I will come later why I've used contactors. Okay, and see here also I've used a contactor. Okay, I'll come later. Okay, why I've used a contactor. And see here what I have done. Now this I have incorporated star Y connection or star connection. Now I have to incorporate delta connection. Okay, so what I have done, I have taken tappings from here, A phase, B phase and C phase, and then I have connected this A phase, or here from A1. See, A1 means C here. A1 should be get connected to C2. So A1 is connected to C2 right here. And see, A2 should be connected to B1. See, A2 is connected to B1. Okay, and here see, C1 is connected to B2. C1 is connected to B2. Okay, so I have achieved delta configuration and also I have achieved star configuration. So to automatically switch between star and delta, I'm using these contactors. Okay, so this contactor is basically automatically switching between star and delta. Is it clear why I'm using contactors? That is the reason. And see, here is a rectifier. This rectifier is basically feeding DC to the winding. So this rectifier is activated when I am pressing emergency stop. So this system is for emergency stop condition, means this situation is for emergency stop. Okay, and this situation is for normal working of motor, normal starting. Okay, is it clear? So let's move to notations. So see, these are the notations. So in control circuitry and power circuitry, I've used certain notations, so this have to be made clear. So this symbol is normally closed contact. This symbol is for normally open contact. This symbol is for contactor. This symbol for overload relay. This SPP means single phasing preventer, and this symbol for rectifier or converter. Is it clear? So let's move back to power circuit. Move to power circuit. So this is motor's power circuit. Okay. So see what I've done. See, from the three-phase bus A, B, C, three-phase bus, I've taken tappings. See. At first, I've inserted overload relay, then single phasing preventer. See, the three phases are coming via overload relay through the overload relay. Okay, through the overload relay to the contactor. See, here I have placed a contactor, that is the main contactor, and from the contactor, the phases are fed to the motor. Okay, and from here and there are, imagine this is a terminal box of a motor. Okay, the phases have come to one end of the terminals, and from the other end of the terminals all the phases are being taken out. See here, like this. That's why I've explained this thing first. Okay, see, all the phases have been come here, A1, B1, C1, and from here A2, B2 and C2, these have been taken out and shorted via the contactor. Okay, that thing I've done here. See, from here the wires have been taken out, and I've used a contactor, a star contactor, and the other end of the contactor has been shorted to achieve Y configuration or the star configuration. And to achieve delta configuration, what I have done, I've taken the connections from here, and via the contactor, the delta contactor, I've made the connections right here. Okay, so I've incorporated delta contactor, I've incorporated star contactor, and also I've incorporated main contactor. Okay, so to start the motor in star configuration, what I have to do, I have to energize this main contactor and star contactor simultaneously. Okay, and after a delay, what I have to do, I have to de-energize this Y contactor or star contactor and energize the delta contactor. Okay, then what will happen? The motor will run on delta configuration. At first the motor was running in star configuration, and after a delay, certain delay, the motor will run in delta configuration. Is it clear? So this section is star delta starters section. And see here, this is the overload relay. This relay is protecting the motor against overload, and this is a single phasing preventer, and this single phasing preventer is protecting the motor in case of single phasing. Okay, so let's see this DC injection braking system power circuit. So see here what I've done. I've also incorporated a overload relay for transformers protection, Okay, and this transformer is basically an auto transformer. So the tappings have fed to the rectifier, and this rectifier is converting this 3-phase AC to DC, and that DC have fed to the windings of the motor. Okay, and to short the terminals, I've used sorting contactor. I've used a sorting contactor. Okay, so to activate this DC injection braking, I have to simultaneously energize this TC contactor and SC contactor simultaneously. Then only the DC injection will take place and the motor will stop immediately. Okay, so what is the theory behind this braking? So see, in normal condition, this is induction motor. So induction motor needs rotating magnetic field for the shaft to rotate. So 3 phases are being introduced to form rotating magnetic field in air gap. So that rotates the shaft of the motor. Okay, is it clear? So if I inject DC in the winding by switching off the AC, what will happen? This DC will produce static magnetic field in the air gap between the rotor and the stator. Then what will happen? Automatically the rotor will decelerate and the shaft of the motor will come to rest. The motor will stop immediately. Okay, so that is the theory behind this braking system. So this braking system I can easily use to turn off the motor immediately, so it can be a good option for emergency stopping. Okay, that's why I've incorporated this DC injection braking system. And to get detailed idea and practical idea of DC injection braking system, watch my video where I have explained the DC injection braking system, and also I have practically shown on a single phase induction motor. So please watch that video. I will also provide the link in the description. Okay, so let's switch to control circuit. Okay, so see here. So these contactors have to be controlled. So to control those contactor, I have to design control circuit. So here it is. So this is basically the control circuit. This control circuit is controlling the power circuit. Okay, so let's decode this. Let's try to decode this control circuit. Okay, so see again, there are 2 halves. This half is for star delta starter and this half is for DC injection braking. So let's focus first to the star delta starter. See here, I've used normally closed contact. This is normally closed contact of overload relay, then normally open contact of single phasing preventer. Here is a trick. What is the trick? When the single phasing preventer gets the 3 phases, its state of the contact gets changes. Means this will become NC. When I charge this bus, when I will charge this bus, automatically the contact of the single phasing preventer will come to NC, right like this. Okay, wait, let me use black marker. Okay, so the circuit is made. And then what I will do, so see what I've used. See, so this is the contact of a single phasing preventer, then I've used stop push button, then start push button. Okay, see, the stop push button is NC type and the start push button is of NO type, and both the buttons is spring return type. Okay, then I have used the main contactor here, the timer, star contactor, delta contactor, and these are the contacts. See, this is the A contact of this A contactor, and the main contactors NO contact, main contactors NO contact, and the timers NC, here timers NO, Here the delta contactors NC, star contactor NC here, A contactors NO, NC, also here NC. Okay, and also there are a few indicators. This indicator indicating when the motor is started, these two indicates in fault condition. Okay, and see here I've used here the NC contact of overload relay, then emergency stop push button, then A contactor triggers the timer. Okay, and here again the contacts, NO contacts, normally open contact of A contactor, normally open contact of T contactors, and then time TC, that is transformer contactor, then shorting contactor. Okay, so and this indicator indicates the condition of injection braking, DC injection braking condition, and this indicator indicates the fault condition of the transformer. Okay, so let's see the working. So let's understand the working. So at first I'm starting the motor. See carefully, observe the process carefully. What I have done, I've started the motor, I pressed this push button. What will happen immediately? See, at first this the contact is being made up till here, the circuit is closed up till here, and as I will short these contacts by pressing the start push button, what will happen immediately? This main contactor will get energized. Okay, and its state of the contacts state will change, means this NO will become NC. Wait, I have to use another marker. This will become NC, this will become NC, this will become NC, this will become NC. Okay, and what will happen? The timer will get energized and this Y contactor will get energized. Means see, this both the contactor, the main contactor and Y contactor gets energized simultaneously. Okay, and with the help of this contact, the contactor gets latched. Okay, since this push button is of spring return type, so after leaving the contact, the contactor should not get de-energized, so I have incorporated this latching arrangement. Okay, is it clear? Now after a delay, the contact of timer gets changed, means this will become NO, and this will become NC, like this. And what will happen? This delta contactor will get energized and change its contact. Okay, and the star contactor gets de-energized. Okay, now the motor is running in delta configuration. Initially the motor was running in star configuration, and after a delay the motor is running now in delta configuration. Is it clear? Okay, and if I press this stop push button, what will happen? This circuit will get disconnected and eventually this main contactor will get disconnected and all its contact will come back to its original condition. Means this will again become NO, and all the contactors will get de-energized and the motor will stop. This is the operation. Also see, in fault condition, what will happen? This circuit will get disconnected, and in overload condition this main circuit will get disconnected, and this LED will be indicating the condition, and this LED will be indicating the condition of overload or single phasing, and the main circuit will be disconnected, and eventually all these contactors will be de-energized and the motor will stop. Okay, is it clear? And see, in emergency stopping condition, now the motor is started, the motor is running. I have to stop this system, the process immediately. What I will do, I will press this push button. I will press this push button, and I have to keep pressing this push button because I have not incorporated a latching mechanism. Okay, so I have pressed this push button. Now what is happening? See, as I press this push button, this A contactor gets energized. Okay, as this A contactor gets energized, its contact state will change, means this NC will become NO. Okay, this NC will become NO, and this main contactor de-energized, all the contactors will get de-energized. Okay, and see here, now this contactor gets energized, the state of this contact has changed from NC to NO. This will be changed to NC. All the markers are not working. See, this will become NC, this will become NC, this will trigger the timer, and after a few seconds delay, this DC and SC will get energized and inject DC to the winding, and immediately what will happen? The motor will come to rest immediately. Okay, and if I release this push button, what will happen? This contactor will get de-energized and all its contact state will come back to its original condition, like this. And now we can start the motor again. Now we can start the motor again. By starting this motor, what will happen? This main contactor will again get energized, its state of the contact will change, like this, like this, like this, like this. This timer will get energized, means from at first the motor started in start Y configuration, then after a delay, what will happen? After a delay, what will happen? The state of the contact of the timer will change, means this will now become NO, this will become NC, and this delta contactor will get energized, and now the motor will run in delta configuration. As simple as that. Observe this. This is what I have done here. I am showing interlocking system. See, I have incorporated NC contact of delta contactor with Y contactor, and the NC contact of Y contactor with delta contactor. See this, NC contact of delta contactor of in Y contactor with Y contactor, and NC contact of star contactor with delta contactor. What will happen? Why I have used these NC contacts here? Because to incorporate interlocking mechanism. What is happening when Y contactor is energized? This will remain de-energized. This contactor will not get energized since it is NO. And if this contactor is energized, okay, and if this contactor is energized, what will happen? This Y contactor will not get energized in any condition. Okay, why I have made interlocking mechanism? Due to this reason. If, say for example, both the contactors are energized simultaneously, then there will be short circuit. Okay, then there will be short circuit. Here also I have incorporated interlocking mechanism, means this A contactor is interlocked with this the main starter contactors. Why? Because if this star connection is means if this starter is working, then I press this DC injection system, means I pressed this switch, then without stopping it will start, means without stopping the motor this DC injection will take place. Then what will happen? This DC will be injected in the presence of AC, then there will be short circuit. So I have provided an interlock between this system and this system also for safety reasons. Okay, means this system, this DC injection braking system is isolated. Okay, this system is isolated and this system is isolated completely. Okay, done. Is it clear? Is it clear? So guys, if you all have any queries regarding this topic, then please comment down below. And if I made some mistake in the then please do correct me. Okay, I'm not a professional, I'm a student, so please understand. And I hope I made something clear. You all get some knowledge from my explanation, and I do these kind of stuffs. And so if you like my video, then please don't forget to like, share and subscribe. Stay tuned with me for this kind of interesting content, and I will provide the circuit diagram in my Instagram page. So follow my Instagram page. The name of the page is Rohit Tech, as the name of the channel. Okay, so please follow my Instagram page. Okay, so for now, bye bye, thank you. We will meet in the next video. Tada, bye bye, see you.